lines formed by joining the points that represent the data figures. Now, for example, we have annual sales of some XYZ company from the years 2011 to 2015. The y-axis here shows the number of products in thousands. So this is 700,000 or 7 lakh, this is 6 lakh, this is 500,000 or 5 lakh. And similarly, the x-axis here shows the years. So we have this blue line representing the sales of this product A, the red line representing the product B, and the green line representing the product C. So we see data points here. For 2011, the sale of this product A was 5 lakh, and the sale of this product B was 6 lakhs. The sale of this product C, shown by this triangle here, was somewhere near 4 lakh and 80,000. Similarly, all these points here show the data in the respective years, and these line graphs have been formed by joining these points. This star marked here shows that figures for 2015 are not the actual one, but based on some projected numbers. So a few points to be remembered before we proceed on solving questions. Pictorial representation of data helps to understand the trend immediately, that is whether the data shows a continuous increase or decrease over some period. So if you look at this graph here, this product B shows a continuous decrease from 2011 till 2015. Similarly, this line graph for C shows a continuous increase. So from 2011, it goes up gradually and reaches this 6 lakh mark in 2015. Whereas this product A first shows a decline and then shows an increase. Now we'll talk about growth and growth rate. I've already discussed the difference between the two in the introductory lecture on data interpretation. Now growth and growth rate can be compared directly through the line graph, which is directly related to the slope of the line. So growth is directly proportional to slope. What does this mean is that, for example, I take this point for this product A here for the year 2013, and then I take this second data point for 2014 for the same product A. Now the greater the slope of this line, the higher is the increase in the growth. So this increases from 4 lakh to about 5 lakh and 80,000. Now had this slope been even more steeper, I'll show you with the change of color. So if this slope was something like this, so this is a more steeper slope. So this goes on to 6 lakh and 50,000. So more the steepness in the slope, the more is the growth. Similarly, the growth rate is also directly proportional to the slope. The more the slope, the more is the growth rate. Also, growth rate is inversely proportional to base value. Now this is a very, very important point. Now what does this mean is, let's say I have a figure of 500 and I increase it by 10, so this makes it 510. So what is the growth rate here? It is the increase 10 divided by 500 into 100, and this makes it a growth of 2%. Now let's take a figure 50 and then I add 10 to it, so this makes it 60. Now what is the growth rate? It is 10 divided by 50 into 100, which is a 20% increase. Now let's take it the number as 5, and now I add 10, so this makes it 15, and the growth rate becomes 10 divided by 5 into 100, and this makes the growth rate as 200%. So what I'm trying to explain you here is that as the base value, now what is the base value here? 500 was this base value, the value on which this growth of 10 is registered. Here the base value was 50 and here this base value was 5. So as the base value decreases for the same growth, that is the same absolute change in the value, the growth rate increases. So it increased from 2% to 20% to 200%. Now if we look at this graph here, now let's look at this graph for this product C, which is the green line. So I look at this green line. Now if you carefully notice, the growth is more or less the same in each of the years, as the slope of this line is constant. So it increases from about 4,80,000 to 5 lakh in this first year. So that is an increase of 20,000 units. Similarly, when it goes from 2012 to 2013, again there is a growth of 20,000. Similarly, as it goes to the next year, again the growth is for 20,000, and for the last year as well, the growth is same for 20,000. So in all these years, the growth is same. So the growth remains 20,000, but the growth rate changes, because in the first year, in the year 2012, this 20,000 was recorded over a sales of 4 lakh and 80,000. Now for the second year, that is the year 2013, the same growth, that is the growth of 20,000, was recorded at a higher number, that is 5 lakhs. So even if the growth was same, the growth rate has decreased. This is what I explained you through an example here, and this is what this second principle says. So the growth of C is gradually over the period, but the growth rate is decreasing as the base is increasing. So the maximum growth rate for C was in the initial years, that is 2011 and 2012. So now we'll try some of the questions on line graphs. So here's the first question set. The graph below shows the end of month market for values of shares of 4 shares for the period from January to June. Answer the following questions based on this graph. Which share showed the greatest percentage increase in the market value in any month during the entire period? So now we'll need to calculate the growth rate for each of the share in each of the month, but we can simplify our lives by just looking at the slope. So the probable answer can be this, because this is a high growth. We can check for B only in the initial months, that is January and February, because here the second principle will apply. The growth is same throughout, but the base is increasing. So I don't need to check the growth of B in all the periods because it is same, and the growth rate I'll check only in this first period, because after this February month the growth rate of B is decreasing because the base is increasing, whereas the growth is constant. Similarly for C, we can check here during the period of March and April because it shows a growth here, and for this graph D I can check only in the initial period, because after that I don't see a much steep slope towards the higher side. So instead of checking for all the months for all the 4 shares, I have reduced my calculation to checking for A in the month of February and March, which is this graph here. Then for B, I'll check only in the month of January and February. For C, I'll check for March and April. And for D, I'll check in the first 2 months. Now, when you make your calculations, your answer will come up as D. I'll calculate for D. So for D, the increase is of 10 in the first 2 months. So it goes from 40 to 50. So what is the growth rate? It is the growth divided by the initial value into 100. So this gives an increase of 25%, which is the highest for any product. You can check for any other value. Let's check for C. So it goes from 60 to near about 70. So 60 moves up to 70, again an increase of 10, but over a higher base. So obviously it would be less than 25%. So we don't need to check for C. Similarly, you can check for A and B, but this value will come out to be the highest one. Let's look at the second question. In which month was the greatest absolute change in the market value for any share recorded? So absolute change is nothing but growth. So again, you will just look at the steepness of the slope where it was the highest. It is very easy. The slope has been the steepest for this product A if we compare all the 4 graphs and in the month of January to March. So if I take this value here, this is somewhere near 115, and this is somewhere near 95. So if you subtract this, comes out to be 20, and this is the highest absolute change. This happens in the month of March, so the correct option here is the A part. So just by looking at the steepness of the slope, you can answer without making calculation. Even this calculation wasn't required. Let's check the question number 3. In which month was the percentage increase in the market value for any share recorded? So the greatest percentage increase, we've already calculated this, that this happened for D, which was 25%, and it happened in the month of February, because we calculated from January to February. So the correct answer is the A part here again. Let's check the fourth question. An individual wishes to sell one share of C and one share of D to buy one share of A at the end of a month. At which month end would the individual's loss from this decision due to the share value changes be the most? So when will he go into maximum loss? So now what the question is asking us is, let's take this first month of January. So if I sell the share D, I will get rupees 40 or whatever the currency here. If I sell the share C, I'll get a 60. So my total is 60 plus 40, which is 100. Now when I buy this share A, I'll have to pay 100. So my net loss or gain in the transaction is 100 minus 100, which is 0. Similarly, I need to do for all these months, for February, for March, for April, for May, and for June. So I formed a table here. As mentioned, for January, I get 60 for C, 40 for D, total earning is 100. I buy A for 100, there is no net gain or loss. When I do for all the months, I have the net gain or loss in this last column here, and the maximum I can lose is 10, which is in the month of June. So the correct answer option here is the D part. Again, we have another question on the same logic. An individual decides to sell one share of C and one share of D to buy one share of A at the end of the month. What can be the individual's greatest gain? So again, the same table I drew in the previous question. Herein, I want to answer what would be the greatest gain in the transaction. As it is very clear, the greatest gain would be of plus 10 in the month of February. So the correct answer option here is the B part. So now let's look at this second set in line graphs. Study the graph below and answer the questions that follow. Let's understand the graph first. I have years on the x-axis. This blue line depicts the sales. The red line with squares depicts the expenditure, and I have equity here. Nothing is mentioned about the units on the y-axis. So we'll just take this as 140 units, 120 units, and so on. In which year is the profit per rupee of equity the highest? Now profit is defined as sales minus expenditure. So what they want to ask us is, if I subtract this sales, which is 80 for this first year, minus this expenditure, which is about 76 for the first year, so this gives me a profit of 4. When I divide this 4 by this equity in the first year, which is nearly 8, so 4 by 8 gives me a ratio of 0.5. So in which year is this ratio the highest? So per rupee of equity means that I have to find out in which year profit divided by equity has the highest ratio. So we'll calculate. So this table here shows the different years. I have this sales value minus the expenditure, and this gives me the profit. These are the equity values, and this is finally profit divided by equity. So if you calculate for all these years, you will get for year 1991 the sales is 92, the expenditure is approximately 88. This gives you a profit of 4, divided by it, this gives you 0.5. Similarly, calculate for the rest of the years. We find that the ratio is maximum in the year 1993. So it's an easy question, but a little calculation intensive. The simple annual growth rate in sales was the highest between which of the following years? Now this means that I have to calculate the growth rate in sales. So I've calculated here in this table. In 1990 the sales was 80, grew to 92 in the year 1991, then to 106, and then finally to 128. I've calculated the growth rates here. This has been calculated as 92, which is the final value, minus 80, which is the initial value, divided by the initial value 80 into 100. So this gives me a 15% increase. So you calculate for all these years. Remember, when you calculate for 1990 to 92, this means you are doing this 106 minus 80 divided by 80 into 100. Whatever the answer comes up here, you have to divide this by 2, because you've been asked the simple annual growth rate, and in the formula for SAGR you always divide by n, which is the number of periods. This is what I discussed in the first lecture. Anyways, this is not going to be the answer. The answer is in the year 1993 and 92, which is 21.75%. So the C part here is the right answer option. Let's look at question number 3 in the set. In which year is the sales per rupee of expenditure the lowest? So here I have to find out sales divided by expenditure, and in which year is this the lowest. So again I form this table. The first column here shows the years. These are the sales in the different years. These are the expenditures in the different years, and this column has been found out by dividing this column here 80 by 76. Similarly, this one is 92 by 88, and you can calculate for all the years. So we have to find out when this ratio was the lowest. This was lowest in the year 1991. So the B part here is the right answer option. Let's look at the next question in the set. In which year is the sales per rupee of equity the highest? So nothing but we have to find out sales by equity. So again I form this table. Sales for the different years I mentioned here, equities for the different years I mentioned here. I've marked an X in two of these cases because I don't need to find out the ratio for these two cases. Why? Because in this case, the first case, the answer is going to be 80 by 8, which is nothing but 10. But here the answer is going to be 92 by 8. Now since the denominator remains same, which is 8, but the numerator increases, so definitely this ratio will be greater than this one. Similarly, I don't need to calculate for this year 1992. I'll straight away calculate for 93, because in 92 the ratio is going to be 106 by 22, whereas in 93 it's going to be 128 by 22. Again, there is an increase in the numerator with no change in the denominator, so this will give you a higher ratio, which is 5.81. Anyways, the answer is going to be the B part here, as this ratio is 11.5. Now let's look at the next set in line graphs. This is a very interesting set, and here you'll find out that most of the answers you can actually tick mark just by a mere observation on slopes. This is what we discussed in the beginning of this lecture. So answer the questions on the basis of the information given below. We've been given the solubility temperature relationships for various salts. So I have potassium chlorate, I have potassium chloride, potassium nitrate, sodium chloride, sodium chlorate, and sodium nitrate, and I have different colors to represent the solubilities. So the solubilities is given in kgs per liter of water. These units are important. And on the x-axis I have temperature in degrees Celsius. So what these line graphs show is that the solubility of all the salts change with temperature. Mostly they increase with temperature. It means that as you keep on increasing temperature, there is more amount of salt that can be dissolved in a given quantity of water. So let's look at the first question here. Which of the following salts has the greatest solubility? So the first, I'll just change the ink color. The first salt is potassium chlorate at 80 degrees Celsius. So potassium chlorate is given by this blue line here at 80 degrees Celsius. The answer is somewhere near 0.4. Potassium chloride at 35 degrees Celsius. So let's look at potassium chloride. at 35 degrees Celsius. It is also somewhere close to zero point 0.4 itself. Now potassium nitrate at 39 degrees Celsius, potassium nitrate is this triangle. This is slightly greater than zero point 0.4 at 40 or 39 degrees. This is slightly greater than zero point 0.4. So till now my answer is potassium nitrate. Let's look at the last option, sodium chloride at 85 degrees Celsius. Let's look at the graph of sodium chloride, and this is again a constant figure at 85, which is near to 0 0.4. So my correct answer option is potassium nitrate at 39 degrees Celsius. So what you notice here is that it's a little difficult to understand or observe the graph since there are so many lines, but once you pay attention you'll find the answer very easily. Let's look at the next question in the set. Approximately how many kgs of potassium nitrate can be dissolved in 10 liters of water at 38 degrees Celsius at 30 degrees Celsius? So I look at 30 degrees Celsius and potassium nitrate is this triangle. So at 30, this is somewhere here, this triangle here, this is nothing but somewhere close to 0.38. And what are the units for this solubility? They are in kgs per liter. So 0.38 kgs per liter at 30 degrees Celsius. Now I have 10 liters of water, so I multiply by 10 liters. So these units for liters cancel out in the numerator and denominator. So my answer comes out to be approximately 3.8 kgs at 30 degrees Celsius. So the nearest answer option here is the C part, which says 4 kgs. Let's look at the next question. By what percentage is the solubility of potassium chlorate? So potassium chlorate is this line here with diamonds. In water is increased as the water is heated from 30 degrees to 80 degrees Celsius. So I have 30 degrees here. So this data point, which represents a 0.1, and it goes to 80 degrees Celsius, which is this data point here. So it increases from 0.1 to 0.4, and we want to find out what is the percentage increase. Remember, it's the percentage increase. So what is the formula? The final value minus the initial value divided by the initial value into 100. So this gives you a nearly 300 percentage increase. So the correct answer option here is the D part. Let's look at the next question in the set. If 1 mole, now mole is a unit of calculation. For example, we have kgs, similarly we have moles. So it gives the amount of a substance. If 1 mole of potassium chloride weighs 0.0746 kgs approximately, how many moles of potassium chloride can be dissolved in 100 liters of water at 36 degrees Celsius? So first let's look where is potassium chloride. So this is potassium chloride and represented by this red line. We want it at 36 degrees Celsius. So at 36 degrees Celsius is somewhere here. So I get this data point here, which is nearly 0.4. So the solubility at 36 degrees Celsius is 0.4 kgs per liter. Now I have 100 liters of water. So how many kgs of potassium chloride can be dissolved? It is 0.4 kg per liter multiplied by 100 liters. Again, these liter units cancel in the numerator and denominator. So this gives me 40 kgs. But now I want to convert this to moles. I know that 1 mole is equal to 0.07456 kgs. So how many moles are 40 kgs? I simply divide 40 by 0.07456, and this will give you the answer somewhere near 536 moles. So the nearest answer option here is the D part. Let's look at the last question in the set. Which of the salts has greater change in solubility in kgs per liter of water between 15 degrees and 25 degrees? So now this is nothing but a mere question or observation. The steeper the slope of a salt between these two temperatures, the higher is the change in its solubility. So 15 degrees is going to be somewhere here and 25 degrees is somewhere here. So I have to look at the graph between these two lines here and see for which of the salt is this change in slope between these two lines the highest. So let's look at potassium chlorate. So I have this diamond line, this does not change much. I have potassium nitrate. So potassium nitrate is given by this green line here. Sodium chlorate. So sodium chlorate is given by this X line here. This hardly changes. And then I have sodium nitrate. So sodium chlorate was this one, this blue line here. This shows a considerable change, and sodium nitrate is this orange line here. Again, it does not show much of a change. So just by observation you can see that the maximum change in the slope is in this blue line here, which is for sodium chlorate. So the correct answer option is the C part here. Make sure that you carefully look at the graph. Like I just made a mistake between sodium chloride and sodium chlorate. These are the silly mistakes which we end up doing in examinations and which we need to be wary of. So let's try the next set. Answer the questions on the basis of the data presented in the figure below. So we have price on this y-axis, 10, 20, 30, 40, 50 till 80. The data points represent the mid-year prices of essential commodities. So I have the years on the x-axis, 96 till 2002. What are the essential commodities? We have rice, egg, dal, chilies, edible oil, and onion. Let's look at the first question. During 1996 to 2002, the number of commodities that exhibited a net overall increase and a net overall decrease were respectively. So we have to number the quantities, as in quantify them. So I have formed two columns here, increase and decrease. We'll go from one graph to the other and find out whether there's been an increase or decrease. What I suggest you is, for this question here, pause this video, find out your own answer, and then look at the solution. So we look at this green graph here. It started from somewhere near 70 and it ended up below 70 for sure. So I have one commodity which ended up showing a total overall decrease. Let's look at this second graph here. It started from 50, and if I draw a straight line here, it ended up a little above 50. So I have an increase of 1 here. Let's look at this red graph. Clearly it started from around 32 and ended near 35, so another increase. Again, for this purple graph, it started from nearly 22 and ended up on the higher side, so again an increase in the overall period. The orange graph is pretty clear. It started from 10 and ended at nearly 18, so again an increase. And for this last graph, it started at 10, whereas it showed an overall a slightly lesser than 10 value towards the end, which is for rice. So this shows is a decrease. So the number of commodities which showed an increase was 4 and which showed a decrease were 2. So the correct answer option here is the C part. Let's look at the second question in the set. The number of commodities that experienced a price decline for 2 or more consecutive years is. So we need a price decline for 2 or more consecutive years. Let's look at this first graph here. It shows a decline here, but then it picks up. Then again it shows a decline here, but then again it picks up. So the green one is not counted. Let's look at the second graph. It shows a decrease here, but then it increases. It shows a decrease here, again a decrease. So this is what we wanted. So we have one commodity which is chilies, which shows a price decline over 2 or more consecutive years. Let's look at this third graph. For dal, it shows a decline in 1999, again a decline in 2000. So we have one more quantity which shows a decrease for 2 or more consecutive years. Let's look at this purple graph for egg. It shows a decrease here, but then it picks up, again picks up, shows a decrease here, again shows a decrease here. So towards the last 2 years, the prices have been falling. So we have another commodity, so I write another one here. Let's look at this orange graph for onion. It shows a decline here in 1998, again a decline in 1999. So I add another one for this commodity onion. And let's look at this last graph for rice. It shows a decline in 2000 from here, again it shows a decline from 2000 to 2001. So I again write a 1 here. Now let's count the number of quantities, the number of commodities. We have 1, 2, 3, 4 and 5. So the D part here is the right answer option, that 5 commodities show a price decline for 2 or more consecutive years out of 6. Let's look at the last question for the set. For which commodities did a price increase immediately follow a price decline only once in this period? So I need a price increase immediately following a price decline. We'll go by the answer options. Let's check the first answer option and rice here. So for rice, we have a decrease and then we have an increase, again we increase, we have a decrease, we have a decrease, but then again a slight increase. So rice is not the correct answer, so we strike out A, because here the price of rice increases twice, once here after a decline in 1997 and once here in 2002 after a decline in 2001. So this is not the right answer option. Let's check for egg for answer option B. So egg is represented by this purple line. So we have a decrease here and then it increases. So we have this once and then it decreases and decreases. So the increase follows only once after a decrease. So egg is okay. Let's check for dal now. If you check for dal, there's a decrease here in 1997 and an increase in 1998. But then again there is a decrease in 2000 as compared to 1999, but an increase here in 2001. So it happens twice in this span, so dal is not the correct answer option, so we strike out B as well. Now we'll check for onion. Now the answer option C is not possible because onion only is incorrect, since we've already checked that this condition holds true for egg. So obviously C will not be the answer option, and the D part is the right answer option, that egg and onion